Would someone put the show notes link or should I do it?
Oh, we're live.
Hello.
Hello.
Hello, everybody. I know no one's listening
Hello.
yet, right?
Yeah.
No, because they don't know what's happening.
It even doesn't say it's happening to us. It says it's preparing. No, it's redirecting. Okay.
Redirecting. Meeting is now streaming. Oh, we get a link. Okay, copy streaming link. That's not what I want. That is what I want. If you're tuning in, we're still getting set up. Couple more seconds here.
Just fast forward the video.
Oh, I can't edit it, even though I'm logged in as Apropos.
Can't edit what?
The show notes. Okay, but someone did it. All right, cool. All right, we ready?
Let's do this.
Indeed.
Hello, and welcome to Apropos, a conversation between Clojure programmers that you can join in live on YouTube. Today, we're going to jump right into the REPL. We're going to pay back for all those times we didn't get to the REPL and blathered on. And we're just going to code up a couple of nice exercises from the advent of code, which is happening right now. So if you're joining us live, feel free to comment in the chat and we will try to address the questions. I'm going to introduce the panel. We have Mike.
Hello.
Mia. Ray.
Hello.
And I'm Eric. All right, let's get into the REPL.
Are we going back into my old REPL or do we need a different one? Or okay. You guys remember
I'll make it to a holiday effort.
Oh, to get the reptile thingy going? Yeah. Do you guys remember the link to it?
I have it. I'm in.
You're in. Okay, I'm gonna join then.
Oh man.
The join tmux doesn't work.
Send my
start tmux.
Yeah. If you're the first one, I'll be in there shortly with you. Join tmux. Let's see. Okay, I'm in there with you.
Cool. And so someone needs to share this with our audience.
I could do that. I did that last time and it worked. So let's not change anything. Stick with something that works.
Sounds good.
See. Yeah. Share. Let's see. I want to share the REPL. Looks like it's that one there. Okay. I think I'm sharing the REPL now.
Yeah, it looks like you are to me.
Awesome.
All right.
Okay, so we have a problem from the Advent of Code suite.
Yeah, and someone, Matthias, were you working on the Advent of Code? And now you're going to watch us do it. That's cool. Just to remind everyone, there are show notes in the YouTube description where you can find the exercise we're going to be working on. We're working on password rules. This one is from day 4, where we are given a bunch of, like, we forgot our password, but we're given a bunch of rules that we remember it had to abide by. The question is, given all these rules, how many different passwords are possible?
Oh, wow. Okay.
So yes. So it sounds to me like, just on first reading, it's like a simple generate every possible thing and just start filtering some out.
Brute force. Yeah.
Yeah.
Okay.
So are you going, Mike?
I'm in there.
Okay. Well, I'll type something. Let's see. So we're given a range.
We can give you the range, yeah.
Yeah, it's like a puzzle input is, should I type it in as a range? Like range 168,630 to.
And heads up, it's the old show notes in the video description again.
Oh, is it?
It's show notes from last week.
I think it's
How is that possible?
9.9, isn't it, Eric? Because it's not inclusive.
Oh, it's not inclusive? Oh, right. Range is not
isn't.
inclusive. Yes, you're right. So I'm going to Could someone fix the show notes? I didn't put them in, and I don't have an edit button. All right. So let's just see how many things we have in this input by itself. Okay. We know that we're going to start filtering stuff out.
500,000. Yeah.
So have we specified what the rules are to the passwords yet?
Well, we know it's a 6-digit number, but all of these are 6-digit within this range. So that's done. The value is what, okay, well, value is what? Two.
Have we explained all these constraints verbally yet? So that people know
we have not mentioned anything.
No, I'm reading them now. I'm reading them now.
I'm just going. I think it's
I'm like, how are you doing this through telepathy or something?
I think it's good. What Eric's doing is just saying like, this is the the broadest set of conditions. Then we've got like the next set and then the next set. So I think we can just reveal it one line at a time. I think.
Yeah, I'm gonna go through the rules. Yeah,
they're fair enough. Yeah.
So, okay, 6-digit number. It's within this range.
Yeah.
Two adjacent digits are the same. Okay, so we have to look for like double digits somewhere in there, right? So in the example they give is that 22. Sorry, what'd you say, Ray?
Yeah, 22 or 33 or 44 or whatever.
Exactly.
Yeah.
Right.
2, but only 2, maybe.
It says 2. It doesn't say.
Like, what if you had more? All right. Well.
Yeah.
That's the problem with these requirements. You have to interpret them.
Yeah.
That's lit. Yeah. Okay.
Okay.
All right.
Everything
so
is
going
being refined
from
as we go along.
Going from left to right, the digits never decrease. They only ever increase or stay the same. So that's another constraint where we'll be filtering stuff out. So you can't have 3, 2, 1 because it decreases, but you can have 1, 1, 2 because that increases.
The example they give is 1, 1, 1, 1, 2, 3.
Right.
The fancy name for that is monotonically increasing.
Well, no, it's not
Is it though?
monotonic.
No, because it's 1, 1 is not monotonically increasing. Is it?
Right.
What is the right word for that then? Monotonically non-decreasing? I don't know. You got to work monotonic into it somehow.
I think it's gin and tonic increasing.
Gin and tonic increasing, yeah.
Then they give a couple examples.
It actually is monotonically non-decreasing.
Monotonically non-decreasing.
Monotonically non-decreasing makes sense, but it's not monotonically increasing. I think that's
right.
So I'm just, trying to in my head.
Yeah.
It's going to be easier to work with the digits, so we should convert these to strings, right? And then I feel like this is just 2 filters. One is to filter out the ones that have 2 adjacent digits the same, and the question is, well, I guess so. They give some examples that maybe will clarify these questions that we had. Like, what if you have more than 2 adjacent digits? It says that all ones does meet the criteria because it has a double 1 and it never decreases.
Okay.
So that answers that question. 2, 2, 3, 4, 5, 0 doesn't because it has a decreasing pair, 5, 0. And then 1, 2, 3, 7, 8, 9 does not meet it because it has no double. So it has to meet all of them, and we know that it has to have at least 1 pair of adjacent digits the same.
Presumably 0, 0, 0, 0, 0, 0 is the first.
That's not
candidate.
Is
the range.
It's
but that's not in the range, so we're safe.
Oh, okay. Wait, where's the? Oh, okay. I don't see the range on this.
It's in the REPL. It's in the REPL.
Oh, gotcha. Okay.
Yeah.
Right, and then there's a part 2, but we'll get to that after we do this one. So I'm going to, I don't know what should we call this. The question is how many are in the range that meet these criteria. So we know we're going to do a count, but I want to be able to see them before we get to that. So I'm just going to call this part 1.
I don't think you want to see them all, though, in fairness. Yeah, there's 500,000 numbers, so.
Right. That's true, too. But I want to be able to get them out of there. All right. So first things first, I'm going to do a double 1 so I can map and filter. So I'm going to get the input, and then I'm going to map str. And then I'm pretty sure that will work. So I'm not gonna print that one out. Then I'm gonna filter, and I'm gonna want to get the ones with double digits. So, let's just do has double digit.
Yeah, just take a leap of faith.
Yeah.
Okay. Didn't match properly.
Maybe add one extra one.
Or yeah, I had too many. Oh, now I got to do this whole shenanigans.
Oh yeah, I don't know if we're not in Rebel readline.
Okay, so we can't
Anyway,
find
okay.
that.
Okay.
So let's do that. Has double digit, and it's going to be digits. Just call it D's.
Okay.
And this means that the two adjacent ones are. I'm gonna just do it like a really easy way. So I'm just gonna say, or equals get ds0, get ds1.
Yeah. Okay.
Yeah. Okay.
Is that no good?
It's fine. Yeah.
I've got nothing else, so this is good. Yeah.
The way I thought about this, by the way,
I don't have.
I don't know if I'm giving the game away, but there are lots of ways of attacking this. But I thought that partition would be an interesting way of doing it. Because, you can create.
You get
windows,
the pairs.
You can create windows.
That's
can
true.
Do the pairs, and also you can create these little windows. So.
And that's probably more safe.
Yeah.
It probably doesn't have corner cases like this one.
Yeah. So
let's see.
Play with it. So if you take a digit, just to keep it simple rather than solving the whole thing. So just take one digit, one input, and just try and partition that in the REPL. Yeah.
Yeah.
Okay, fair enough. You can do it here. Yeah. Partition DS2. Yeah, 1. Yeah. Then we'll see what happens. Well, it's not that, is it? Okay, it's numbers you want.
Oh, you got to make a seek. Maybe just call seek before you call it.
No, partition 2.
You want numbers for a start.
Yeah.
Okay. Oh, I'm sorry. Yeah, it's complaining.
1, 2, 3, 4.
No, I think you're right.
It's
partition.
It's
partition collection. Partition.
Yeah. So
was it right?
The one it's complaining about is 1 isn't a collection.
Yeah.
So
it should be partition 2, 1 collection.
2, 1. Okay.
Yeah.
So you've got the DS in the wrong place. It should be at the end.
There you go.
Yeah.
All right. So 1, 2, 2, 3, 3, 4. That looks right. It's giving me adjacent pairs.
Yeah.
So I mean, just for the audience at home, I want pairs. So that's what the 2 is, and then the 1 means only move forward 1. So typically you wouldn't have the number there, and it would just use the same number, and so it would give you that.
Yes.
But with the 1, it's saying just move forward 1 and give me a new pair. Yeah.
It's like having a little sliding window, isn't it? That's why I like this approach, because you can very quickly find the doubles in this way. Right.
Okay, so we have this partition thing, and so we want to know if some,
yeah.
Apply equals.
Yeah, sure, yeah.
Apply equals. No, that's wrong. It's not some. Some. No.
Yeah. You forgot the percent in the anonymous function.
Yeah. You're right. So false, but if I put in a 4 there, I should get true. Okay. So there we go. We have doubles. So I need to define that function.
Defen. And put a question mark at the end. That's bugging me. You need to put a question.
What did I call it?
Oh, yeah.
I wish I had autocomplete in here.
Yeah.
Did I run the wrong thing? I just ran CLJ.
Right. There's probably an alias for Rebel. But
just open it up again. Then why not? It's only going to take you 2 ticks.
Yeah. How do we do it? Can you do it?
Yeah. Let's see. Let's get out of this. Control D. You see what the alias is?
Ooh.
Rebel. Now we'll be in a Rebel, I think, and we'll have like all the goodness.
Yeah.
Cool.
That's gonna be good for us.
That
taking its
will
time, though, huh?
make it
It's
easy.
Yeah. The Rebel has not yet yelled.
All right.
It took its time, but it's there.
Okay. So we gotta.
Oh man, I can't see this.
Oh the shit! The colors are all.
The
fucked.
colors are a little
Hey,
much, yeah.
Bruce.
We
He's
haven't
assuming
blamed
that we're
Bruce in a
black
while.
and white. Yeah, I mean, I think we did this before. I could probably change the color scheme of this thing.
Mine looks fine.
Maybe it's flip it to a dark.
Oh, are you in a black
dark,
Rebel? Oh.
Black Rebel.
I have a dark background.
Yeah, then it
Yeah,
looks
see, I
alright.
don't.
Oh,
and that's
well, we're at-
Oh, I didn't see how it looked on
That
yours.
is
Oh.
not the one in Zoom.
The mux, yeah. So you could change it in Zoom, so it would be all right. Can you change the colors on the fly, Mike?
Let me try. Let me see
Oh,
if I can
wow.
do that while you guys are looking at it.
I don't know if we need to change colors on the fly. We need to change the colors on the terminal.
Oh! I see.
On the fly or the
Okay.
terminal.
Is that
Either one.
Is that not an Americanism on the fly?
Oh, no, it is. I'm just making a dad joke.
Hey, come on, Mia. We've all got our places on this podcast, you know.
There, I
Taking
did
our
it on
job.
the
This is like.
fly.
All
that's
right,
nice, that's
beautiful.
beautiful. Yeah, we can see it now. Yeah.
The Wizard of Oz just did that. So, all right.
All right. So
Pay no
that's
attention.
input. Sorry, y'all couldn't see me typing, but that's fine. And then we had this new function called has. No, I'm not even going to put the has. That's a digit,
But you must end it in a question mark. Otherwise, that's going to
double
bug me.
digit.
Double digit.
Thank you.
And it's these.
Yes.
And we're going to sum.
Sum without the question mark, because the other one is checking for nil, right?
Right.
Yes. Okay.
Apply equals, which is kind of a hack, but I'll allow
yeah, that
it.
bugs me too. Yeah.
Yeah, we'll come back to that one. Yeah.
Lose points for style for that for some
Okay,
reason.
just to check
Yeah.
because it's totally retyping it.
Mhm.
1, 2, 3, 4 should
Mm.
be false. Well, I could turn that into a false.
Oh, that would be better. Yeah. We need
Oops.
a Boolean. Command
Bruce.
base.
Oh,
Okay.
I got to go to the end. Okay, there we go. So I could
Mhm.
turn that into, I know because sum is actually looking, why is it returning nil?
It can return the first thing that does match, right?
Right. The first
In case it's useful to
value
you.
of the
Return of the
function.
predicate. Yeah.
So that's why
Yeah,
it's
so just do
true.
Boolean on it. Yeah.
Boolean.
Boolean's nicer. Yeah.
Just a yeah.
All right. Now
Mhm.
we know if we have doubles, so we can filter the doubles, right? I'm going to make it take the range. And we're going to do, double input
Mhm.
map str filter double digit. And then I'm going to count it.
Okay.
All right. Cool. Yeah.
Part 1 input. Ooh,
Take a long time.
hello.
Hello. Yeah.
Okay, we got it. Okay, so
Oh,
it's about half of them.
Yeah. No, it's quite a lot still.
All right.
So we have to go the increasing way then.
Right, now we have to say, are they increasing? Oh, but then that's the same thing,
We
right?
can,
We
we can just use a
it again.
partition for that and then just check and
Oh,
see
yeah.
if they
It
they
is
count
greater
each
than or
other.
equal.
Mhm.
Yeah.
Yeah.
All right, so now we're going to do...
Partition is cheating.
That's so cool though.
Sorry, yeah. I mean,
Clojure's cheating for this. You're supposed to be using like C and have to do all this stuff
Yeah.
yourself.
Yeah.
So this is I'm going to say
feel like it was
non
cheating using partition a bit.
decreasing these. Now we have to turn them back into numbers though, right?
No.
Or do we? Because they're ASCII
you do.
characters. They are comparable, right?
Let's check. Yeah, let's check. We're in the REPL. We can check.
I converted them to numbers, but I don't think it works if you
Do a less than. Well, less than wants numbers, right? But you can
Yeah.
compare. You can call
Compare, let's say 1 to
good.
2.
Yeah.
So it's less than because it's -1. And if we do compare 1 to 1, oops, we get 0. And if we compare 2 to 1, we get 1.
Positive.
Oh, right. Okay.
Okay, so this way we can save a little bit of parsing. So this, what did I call this again? Non-decreasing.
Non-decreasing.
I feel like I should reverse it, check if it's decreasing. No, that's fine. All right. So let's do partition 2, 1, Ds. So we're kind of doing the same work we already did. But that's okay. So sum equals, so the decreasing is going to be a 1, right? Apply
0
compare.
or 1 actually. 0 or 1 are okay.
Well, I'm going to negate it. So
just look for 1.
Wait, but if decreasing is 0 or 1 and increasing
0
is
is okay.
only negative. Yeah,
Yeah.
right, I'm sorry. Oh, so we want 0 and 1. We want 0 and -1.
not. Okay, so let's try it. All right, so give me one that it says should work. The 6 ones. None, that's true. Okay, but if I put a 0 there, false.
Good enough for government work. Let's move on.
I think, yeah. Well, let's try an increasing
Yeah, let's
just
try
to
an
check.
increasing, yeah.
Okay.
Yeah.
There we go.
Right.
All right.
Are you convinced? It seems like it's correct. Yeah.
I'm convinced. What I'm kind of sad that we are now doing the partition twice because it already took a long time.
Can we could
Well, we
Yeah,
can,
we could do it up there after the
together.
map.
Yeah.
we could
but let's
also
see.
use we can go to a reducer next door.
Oh yeah.
Use reducer.
Yeah, reducer's the next step here.
We could parallelize it.
Yep.
Okay, we had a part 1 input. Okay, it should take about twice as long now.
Oh, but it was working on less results for the second phase, right?
Oh, that's true.
Like it's further reducing. Yeah.
So is that correct?
I
No.
can see all numbers. I know all numbers. So yes.
That is not correct. No,
Oh.
That's not the right answer. Ray
that's not
says
the
no.
right answer. It's a lot less than that.
What did we do wrong?
So we.
Let's read it again. How many different passwords within the range given in your puzzle input meet these criteria?
Is the filter giving us both of them, both sets of conditions?
Oh, yeah, that could be it.
What do you mean? It's two filters
it's
in
like
a row.
And. It's kind of an and, yeah. So it's not an or of all these rules. All the rules have to be matched, right? Okay. So there's some more
It's
stuff.
definitely wrong. It's definitely wrong.
Okay.
So you're saying that the answer is there's supposed to be fewer matches
A lot
than
less,
this, a lot fewer.
Yeah.
Okay.
Like less than 2,000.
Oh.
Okay, we're off by a lot then.
Yeah.
Well, maybe we could like look at take the first few part of the range and see what it looks like.
Yeah.
Like maybe display a page or two of them and see.
How about we do
like take 20 or something.
Yeah, take 20.
That sounds D&D aficionados. Yeah.
Clojure.pprint/pprint. I don't know if Rebel automatically pprints, but I'll do it.
Okay.
Whoa, that's not right.
Nope.
The non-decreasing did not work. Let's see.
That's right. Yeah. So.
What?
Something's up with our pipeline here.
The pipeline is a bit fucked. Maybe it's the non-decreasing should go first.
Maybe put a question mark on non-decreasing. I don't remember if you.
Oh, thank you. Well, that is decreasing though.
Oh.
So our function is wrong.
What's wrong with it? Okay.
We wrote it. It should be correct.
Come on.
Okay. Equals 1.
I think
Apply,
this, by the way, I
compare.
think this not equals not something is a bit weird to me, but yeah, okay.
Well, you have to look, is there 1? And then you want 0 of them. So you not it. Okay. So
It should be
equals.
-1. It should be 0 or 1, shouldn't it? It should be equal
Right,
to
but
0 or 1.
Right. And so we're looking for, they should all be equal to 0 or 1.
Mm-hmm.
We can't have any 1s. So what I'm looking for is all the 1s, and then I'm negating it.
Wonder if
I'm too stupid for that.
apply is working the way we think it's working here,
Mm-hmm.
or if it's going over.
Uh-oh. What was that? Let's see. Apply. So let's
Oh,
do it
that's a
one
good
step at a
point.
time. 2, 1. Okay. So what was the number that didn't work? 168
633.
3.
633.
Right.
Okay. And so now we're going to apply, compare to 1, 6, right? I could map
I think it's
over
because
that.
the 3 is kind of true. It's the 6 is false.
Oh, -5.
Yeah. Okay.
Oh, so we have to do
yeah.
positive. Positive.
Okay.
Okay.
Yes.
There we go. It's
it-
true. It just subtracts them.
Pause? Question mark. Yes.
All right. Now let's do our part 1 input. Do they look right now? Yes,
looks
they
better.
look right to me.
Yeah.
All right. So let's, we got to redefine part 1 to get the count again. Count. Okay. Woohoo!
Correct. That's the correct
That's
answer.
correct. Yay!
answer.
We got it. Gosh, what would we do without the REPL? We would be like
Oh,
reading
man.
and
Yeah.
rereading the code.
Yeah.
So, folks, if there's any lessons, like just try one thing and look at if it looks right. I mean, that's what we did. We got the wrong answer and we just looked at the output, and then we looked at one expression in there and saw if it worked. And whoa, what is that?
Someone's incoming.
Someone's calling me. Okay. Next part of the problem is part 2.
Part 2. Okay.
Part 2, yeah.
Okay, so now there's one more detail so we can narrow it down. Remember, we're trying to find the password that we lost. We knew it followed all these rules. So now we only have 1,600 to try, but we found a new rule. The 2 adjacent matching digits are not part of a larger group of matching digits. That's harder.
What?
So that means that we can never have like 3 in a row.
Yeah, like you were saying at the beginning, Mike. So you can have 4-4, but you can't have 4-4-4.
Oh.
But you can have 2 things repeated. So you can have like it's saying you can have 1, 1, 2, 2, 3, 3.
That's okay. All right.
Right, because all you can only have double, not triple.
Oh, it's also
So
a bit weird because the last one you can have 1, 1, 1, 1, 2,
Yep.
2.
That's right. This time you cannot have. Oh wait,
Wait, but
That's
isn't
weird.
the group of 6 ones part of a larger group?
who makes their passwords like this? Honestly, this is ridiculous.
The problem isn't us. The problem is the element.
Yeah, just get a reset password email. Come on.
The reason why 1, 1, 1, 1, 2, 2 works is because the 2, 2 qualifies. The 1, 1, 1, 1 does not qualify.
I see.
So the reason why, if you could, so you are allowed to have.
You
as long
aren't
as you've
allowed to
got
have 3 in a
single
row.
pair,
Hmm.
You're okay, but you have to disqualify any pairs. Any if you have a pair, you're all good. If you have a triple, you're bad, unless you've got a triple plus a pair.
If you have a
Or
triple, if
quadruple
you have
plus
a pair, you need one of exactly two, and then the
Yes.
rest don't matter.
Yeah, exactly. Yeah.
Oh, is that the way to look at it? Okay.
Any
So
other big
you
groups
can have
don't matter.
Any number of you have one pair, but that so you have to basically find all the pairs, and then
See if they're
disqualify
adjacent.
any that are part of a larger group. Yeah.
This one is tough. Okay, but we know that they are monotonically or monotonically
That's still
non-decreasing.
true. That rule still applies. Yeah.
So that means that if there are 4 ones, they have to be next to each other. You can't have 2 ones and then some other number and then 2 ones. You have to have them next to each other. So we can do, I mean, the hard way would be like a take while equals or something, but we can also do frequencies. We run frequencies on it. We count up each one. And if we have a group of 2, then we're good. And if we don't, we're bad. Is that right?
I'm not convinced of that.
I'm not sure about that. I've played with that a while. I'm not sure I can make it work. But let's
So-
play with it in a REPL. That's always.
You're saying
what's
if you
Let's
have
do-
it, you know.
If you have at least one group of 2,
You need to have one group of 2, and then basically the rest are the rules that we have already. But the group of 2 can't, you can't have a group. You can't. What we're looking for is 2 in a row, and it might be part of a group of 3.
it might be part of a larger group.
Exactly. But
Wait,
we
but-
need a group of exactly 2.
But groups of 4 are fine.
No.
Groups of 4 are fine as long as you have a group of 2.
Right.
Yeah. The
So
point
group-
that
yeah,
Eric's made
so-
is that you must have a distinct pair
Yeah.
that is not part of a larger group, and everything else doesn't matter,
Right. But
except that it's monotonically increasing. Still.
All right. So this one is in, right? But-
monotonically non-decreasing.
This one is in, right? But this one is out. 1, 2, 3, 4, 4, 4. This one is out. So notice these have a 2. The first 2 have a 2. The last one does not have a 2. And so that is what I'm going to look for. Are any of the values equal to 2? So,
Oh, right. Okay, that makes sense.
That could be useful. Yeah.
so because we know that it's monotonically non-decreasing, it means that we can use that property
That's perfect.
and just
actually.
count
Yeah.
them
Okay.
and not have to build the groups.
Yeah.
Okay. Yeah.
Okay, so
It's worth trying. Yeah. I think that's.
So look, this is what I'm going to do. What's the function that takes a map and turns it into a map with the values and keys reversed?
It's from the Clojure set, isn't it? Inverse map or something? Or
Yeah.
invert
Clojure
keys or
dot
something?
set.
I think it's invert map or map invert. one of the two.
Invert or map invert or invert map. Yeah.
Does this not have completion?
Maybe it
Oh,
hasn't
maybe it's
been.
not required.
It's map invert.
Map invert. Yeah.
Clojure dot set / map invert.
Okay.
Okay. So if I map invert this one,
The frequencies of that.
that gives me 1, 3. And so it doesn't contain 2.
Right. Okay.
Not contains
2.
2.
Okay.
Wait.
So you just want to contains 2, actually, don't
Yeah.
Yeah, contains 2. Okay. Yeah.
And
So let me
let's-
type this in. Defen.
Well, let's try it with the middle case there, the 1, 1, 1, 1, 2, 2.
Okay. 1, 1, 1.
Yeah.
So I need to take out the not. Hold on. Boom. So that one is true. And then this 1, 2, 3, 4, 4, 4 should be false. Okay. So what do we call this?
What
Group
about-
of 2.
Yeah.
And then I'm just going to copy this. I'm thinking also we don't need that first map anymore because this is also testing that. This should be part.
You mean the first, yeah, you mean the first filter?
No, the first. Oh, yeah. Sorry. The first filter. That's right.
Yeah.
Oh, it won't let me do that. Okay, here it is. So we can get rid of that, or should I leave it for now?
Maybe leave it for now and then take it out after and see if it changes the answer.
Filter group of 2. Okay, part 1 input.
It's the correct answer.
Yay! Okay. But let's see if we can get rid of this. It's let's see.
Yes.
All right.
Yes. Yeah.
Even quicker. A lot quicker, actually. Yeah.
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 It's then it doesn't have to do the partition twice.
Yeah.
Okay.
Very nice. Yeah.
All right.
Well,
That was a quick advent to code.
Well, not so quick. It's nearly 40 minutes in, I think. So,
are we getting any comments?
But the
this is day
perfect
4.
timing, actually, wasn't it? But the
Yeah.
perfect timing,
yeah.
Yeah, I didn't go this way. I went with partition and I went with a reduce function on it. But this
Ooh,
is.
can we
even
see
nicer.
Raiseway?
Yeah.
Yeah.
Let's see your code now.
Well, is it cheating just to type to copy my code in now? It seems a bit shit. Yeah.
I'm wondering if we don't do partition twice now. So we don't have to worry about that.
It could help with part 1 if you're trying to optimize part 1.
Yeah.
That's true. Right. This is actually part 2, I should say.
Yeah, I can't access the REPL because I haven't given Mike my shell, my SSH key, and also
They're locked out.
yeah, I'll do it.
No
I'll do
REPL
it
for
this
you.
week. Yeah, unless I can fix up the thing. But yeah, basically, I used reduce rather than filter, but it ends up being the same thing, I think. But I think this is faster. This is a lot faster.
I love
The
frequencies.
frequencies is the killer. Yeah.
Now, if we didn't have the non-decreasing, it wouldn't be you couldn't use it.
Mm.
You know, we're definitely, it's called group of 2, but it's not true because it only is group of 2 in the context of after we've filtered out all the decreasing ones.
Mm-hmm.
Yeah. It's also not really group of 2, but
Yeah, it could use a better name maybe. Yeah.
but let's not fuss about that. Yeah.
Yeah. 2. I mean,
What would you call that?
I would
It's
call
exactly 2, isn't it?
has group of 2 or has
Exactly
repeated digit one at least exactly twice.
2. Has one pair.
Repeats digit twice because
No,
I would say
has one pair because that's
what it is. A pair, yeah. So
Only
as long as
one
we're
pair.
clear that a
One
pair
pair.
doesn't mean has pair,
One pair though, because
at least one pair.
no, it's one pair, isn't it?
Exactly one pair.
And it's not exactly one
I
pair
say one's at least one.
because it works on
Oh yeah.
And the one.
yeah.
1, 1, 1, 2,
Oh,
2,
okay,
2.
yeah. Yeah. Okay. So has pair is a good name for it.
Right, but what it does that it, I'm
It
well.
would
Let's see.
fail in that case. Yeah. 'Cause
If you
it's
put a 1
assuming-
here,
Yeah.
this is going to say true.
Right.
Yeah.
And so I don't know if that
But
are
that's
those pairs.
That's not optimized for a correct program then.
Come on
Because
now.
you're not allowed to pass things to it that are decreasing.
Yeah.
Right. Okay. So that
But
would
it
be
is a
part
bad
of your
assumption.
spec.
Like it's like this function depends on the other stuff having operated on things. And
Yeah.
Well, that's why, if you name it right, it could be correct. I'm just wondering if pair implies that they're next to each other.
Yeah, that's true. Although it doesn't necessarily. I mean, it has pair.
No, right.
You could loosen your interpretation of that name.
Yeah.
Has repeated digit. Has 2 repeated digits. I mean, it depends how long you want to go on this thing.
Right. Exactly 2 repeated digits.
Yeah.
No, I think has pair is good.
Yeah.
And so then the the non-decreasing, I think that one is right.
I think that's right.
The name, double digit. Yeah. I like how we got to get rid of the double digit filter.
You know the filter, can't you use something like and a filter blah and blah?
That's what I was
rather
wondering.
Than,
Yeah, you could,
2 filters.
yeah, you could
Like,
filter by
fuse them together
comp
somehow?
or something. Yeah.
Yeah, you could
just say-
fuse it.
Yeah.
You say and then it would be more better.
Right. Or you could use transducers
Well,
to
it's-
fuse.
Yeah, it's more complicated. Yeah. Why not?
But yeah, how do you it's like every pred?
Yeah. Let's
What is
see.
that called?
That
Every
smells
pred.
like that's right. Yeah, every pred. Maybe with a question mark on it.
Non-D.
Yeah.
Oh, I didn't.
No,
even know
that was
I was
auto-
It's
thinking
not,
about
yeah,
the
it's
thing.
not a question mark. It's
There's not a
every
question
thread.
mark. Okay,
Yeah.
thank you. All right. Okay. Is that right?
I just learned a very useful function from core.
Yeah.
Yeah, it's rarely used, but it looks cool, right? Like juxt.
Yeah, I don't yeah. I'm not a big fan of it, but that is the right way.
I have a very specific use case for this that I
Did that give the right answer? Is that off by a little bit, or is that the same?
That's the
For
original
part 1.
answer, actually.
That's the original
part
answer.
1 answer, yeah.
Okay. So every pred worked.
Every pred worked. That's actually I quite like that. That's Isn't it interesting to time it? If you do 2 filters, if we just do time part 1 with the
Right.
old filter and time part 1 with the every pred.
Yeah, to
Is it
see if the
actually
fusing
quicker?
even helped. Yeah.
Because it's all lazy sequence to maybe is it all just
Chunks
kind
it
of
up.
like
Yeah.
chunks it up and it doesn't really matter. Yeah.
Right. It's all garbage, like ephemeral garbage that
Yeah, it'll be interesting.
will just be thrown away. Okay, here's the time on that one. And then if we redefine it as it was before
Mm-hmm.
and time it. Oh wow,
Quite a lot,
significantly
actually.
longer.
Yeah, that's
Yeah.
a lot. That's a lot better. Yeah.
I wonder
That's a
if we
50% speed up there. Yeah.
Yeah, I wonder if we can't do the partition once. So we map it to strings and then we partition. We map partition over it.
Right.
And then-
that makes sense. Yeah.
And then, but I mean, then the functions are not taking in strings; they're taking in these lists
Yes,
of partitions.
Yeah. That's
Yeah,
that's
but
how
that-
I did it in the end. Actually, I passed in pairs to the functions.
Yeah. Did it speed it up?
I have no idea. Just
'Cause
I
the
just
problem
I
is-
went around it a different way. So yeah.
Okay.
Yeah.
It seems easy enough to try, right? You would just add that partition thing in the pipe.
The thing is, it works for the part 1,
Yeah, it would mess up things.
and it would mess up part 2 because part 2 you only need to partition it once.
Hmm.
We could
Oh, Ed Bowler suggests a transducer.
yeah. We could try our
Of
transducer.
course. Yeah.
All right. So transducer, we're going to use comp instead, right? And
Mm-hmm.
I don't know how to do this. I don't do it that often. It's not.
That looks right so far. Yeah. You comp all those things together.
And then we do like an into. We need to count them, right?
Yeah, you might have to do an into vector and then count the results
Count
in
at the
vector.
end, yeah.
Okay.
There's
Into.
as a first
Input.
cut. Yeah.
Okay, but I don't want it. I want to count this. Okay.
Yeah.
I'll time it. Why not?
Why not? Yeah.
Maybe also see what the answer. Okay, good.
It's actually slower. It was slower than the first one.
Yeah.
Rather
if there was
than
like
the every pred was faster.
Oh,
maybe
that's
if you
right.
reduce, like transduce to get the count somehow without putting it into that vector. Yeah, some way to avoid putting it into another collection and then counting that collection.
Yeah.
Because that's the idea about the transducer, isn't it? That you don't need this second.
So what is it? Transduce?
Yeah, maybe transduce takes
Takes the transform, an F, and a call. Okay, so it's just like reduce.
Okay.
Gotcha. So we're gonna reduce plus, but we get a transform
Or reduce
in there.
maybe inc starting with 0. Transduce.
Inc only takes one argument, so
Okay.
you need plus. So plus 0. Oops, 0.
Okay.
Nope.
Oops.
Okay. Let's see. Whoa.
Oh, you can't add
because
a
you're
number to a
doing-
string. Yeah, because we map them to strings.
Up into strings, yeah.
Oh, you're right. Okay. So we can't use plus. Inc wouldn't work though.
And Moira Hansen suggests partition by identity for our double digit one, I think.
Oh, okay.
Which
Pulls out the pair.
yeah.
Partition by identity. That's a good
that's
one.
Cool.
That is a good one, yeah.
That's really cool.
Yeah.
Ooh. Wait, no, sorry. I meant %1. I want to throw away. I'm just going to write it as a function.
Yeah.
Fn, we need the count, and then we're just going to ignore that one, and we're going to inc c. Yeah? Okay.
Go back and do the Moira. Yeah.
What?
Ouch.
Wrong number.
It's only passing one argument to it.
Yes.
So maybe you can just transduce inc. I don't know what's going on there. Let's see. What?
Does my F need to be different?
So is that a reducing function right there? What is that?
Is the F at the end or at the beginning? I mean,
Yeah, do a docstring on transduce. I can't.
Transduce. So it's the transform.
Okay.
It's the function, then the
reducing function.
init, and then the call.
Okay. And the function should be a reducing function, right?
Let's do a doc.
Hey.
Uh-oh.
Uh-oh.
Transformation of F, XF. What if init is not supplied, F will be called to produce it. Okay, but we're supplying it. F should be a reducing step function that accepts both 1 and 2 arguments. If it accepts only 2, you can add the arity one with completing. Returns the result applying the transform XF to init, but what should it return if it's only got 1 argument? All right, let's try this again.
I think, as an aside, I think Christoph Grant had a count transducer in his Xforms library.
Ah,
It'd be kind of nice to have something like that.
I'm just going to make it
Oh,
return
man,
inc c.
Ed says we need the completing call.
Yeah, to make it happy.
Yeah.
Maybe
What
that
is completing?
Maybe if you just wrap your little function that you're doing with completing, it'll then add the arity that you need.
Yeah.
This is the kind of stuff that you don't use frequently enough to even understand, though.
I know I don't do many transducers. I know people do, but man, my code just
not
gets
part of
so
your-
complicated.
So no, it's getting messy.
Okay.
If it's under 2.6.
Oh,
it's
okay,
just
but
got
it's
a lot
still slower.
It's got a
It's
lot
still
slower.
slower.
In fact, it's got. So as slow as this, almost as slow as the slowest one so far.
Yeah.
Is that slower than the one where we made the vector and counted it?
I think it actually is. Yeah. Because that
What
was 2.9 or something. Yeah.
Wow. I don't understand. I thought this would be the fastest possible thing because it doesn't even make a collection. It just
Right. Rips through and
rips through and inks it.
Maybe ink is more expensive because count is very fast. Yeah.
Well, yeah, once you've made the collection, the count is just a lookup.
a one
Just
up.
Yeah. So
Order one.
adding ink is quite a overhead maybe.
Oh, because you're adding one each time.
Yeah, that's true.
Yeah.
But an into, I mean, the into, does it add one thing at a time? And it,
No,
or does
I don't
it?
think so.
It adds them in
can-
chunks.
It can
Yeah.
actually internally reduce.
Yeah.
Huh.
Like if you do into a vector, if the thing is internally reducible.
What if? Okay, let's go back to that
Yeah,
reduce.
it's interesting. Yeah.
I mean, that said that into one because that one was faster. Oh, there it is.
Okay, that one
What
there.
if we,
yeah.
What if we did like that into an empty list? Would that be faster?
Okay. That's a good question.
We've got 2.6 to beat. So we're still a bit slower, but
Yeah. What about? I mean, vectors are fast, but
okay. I feel that's going to be a lot slower, but okay, go for it.
Oh,
Fuck, it's actually faster.
Okay.
That's the fastest so far.
Putting it into a set.
the other thing I was thinking is,
The intuition is not obvious.
yeah,
Not mine anyway. I've got bad intuition. That's obvious. Yeah. Benchmarking is good.
isn't there a thing called sequence
There is.
Yeah.
like this? Is that right?
Yeah.
Takes an X form and a call. All right, let's try that one. It's basically map, right? Just maps the transducer over.
Yeah, maybe that's a good way to think of it.
no.
Not as
That was
fast
still
as the
faster.
There's
set.
also the
Yeah.
There's the eduction.
Oh well.
Oh boy.
Now
I mean-
I would.
My God.
How though? What is it?
Or-
Where do you put it?
Are you just making up
You'd
words?
have to look it up. No, it's in there.
What if we convert the input to a different collection, one that is
By
like
the way, the other thing that I did, which is kind of, I don't know if this is good or bad, but if you could potentially order things in a certain way where if you're using a reducer, you can essentially stop because you know that you've kind of you've got to the end of the possible values, you know.
Eduction is a geology word.
wait, Ray, you can stop at some point.
With a reduce function, you can pass back reduced, and that stops the reduction occurring.
Right. Yes.
Yeah.
You can do that with the transducers too, I believe.
Yeah, exactly. Yeah, you can. Yeah. So if you
like
if
a
you,
halt
if you
or something
kind
like
of,
that. Or
yeah. So if you kind of know that
remember which one it is.
if you,
Halting
if you
or
can-
something.
It basically says, "Don't feed me anymore. I'm done." You know.
But how do we can't really do that,
What would you
right?
do with this one? Yeah.
Because we need to count all of them.
Yeah, you need to sort it in some way. Yeah.
What if we did reducers
Mhm.
so we can do it in parallel?
Right. No, that's a library I haven't used in a while.
Yeah. But so we use fork join on this,
Mhm.
but could we really do that? Well, we could check them all in parallel. No?
It is a parallelizable problem. Yeah. You have all these passwords that you're just trying to call out and
Mm-hmm.
fork join back down to one answer of how many there are.
There's 500,000 of them, so in theory you can partition stuff off.
Yeah.
2.5 seconds is 3 seconds, a long time in the computer world, isn't it?
Yeah, exactly. So I'm thinking something like, so you got this vector of the inputs, because it has to be a vector. It has to be some chunked thing, right? That it can easily parallelize. It's a tree, basically. And then you...
I'm sorry, I got distracted. Eduction is really interesting.
Right. It's a reducible thing, right? It's like, it doesn't realize a sequence, but you can use it as a collection to to reduce. Is that
Well,
right?
it's really, it brings deep surface rocks.
She's talking about geology.
You're talking about the actual
Yeah, the subduction zone and the adduction.
Well, so it occurs at subduction zones, but it brings really, really deep crustal rocks up to the surface via a very fast exhumation.
Okay.
That comes from the pressure of gravity acting alongside the subduction and creating like a reverse pressure cell. I'm trying to understand it. It's nuts.
Wow.
I
So
still
we
don't
need
understand.
a subduce keyword in core.
Yeah, I still don't
Subduce.
understand Clojure reduction. But
Educe.
Educe.
oh no, I have to go. It's 1.
Yeah.
Oh.
Okay.
Well,
We've
I think
done
this
our
is a success.
Yeah, I
Yeah.
think we've done good. Yeah, and I think we should do more of this. Yeah.
Someone is wondering if we're getting JVM jitters because we're not getting enough of the JIT going.
Maybe.
Could be. Could be.
This is also a Linode. It's a shared VPS, whatever you call that. You know, there's other things on this box too. So, you know what I mean?
Gotcha.
Yeah.
Yep.
We'd have to
Not a real
I'd have
test.
to micro-bench it. But I think we kind of see some changes though. At 3 or 4 seconds, I think you're not going to get too many
I mean, when it's more than a second difference.
Yeah.
But then, there are some of these advent of Clojure problems where it does matter, where you're like, this thing is taking 6 hours through the night. But
Yeah, this one was a lucky one.
Yeah.
Great for doing on a show.
Let's say goodbye to everyone and happy Christmas and Merry New Year.
Yes.
And all
Oh
those
my
kind of
goodness.
things,
Is that happening?
It's advent of Clojure. Yeah.
Christmas? Okay. So, yes, happy Christmas, Merry Christmas, depending on your proclivities.
Season's greetings, as they say.
Yeah.
Happy holidays, as you lot say.
Happy holidays, all.
Yeah.
I hope everyone has a nice time.
Yeah. Parentheses to everyone.
All right, subscribe to the channel and you'll know the URL to this thing next time before we do. Because we don't know until we click a button.
It is really upsetting that we can't give people a
link.
Link ahead of time. But it
Exactly.
just has to be exciting. Yeah.
Yep.
I think the discovery, the excitement of it, that's all part of the fun.
You have to be lucky. You have to be waiting for it.
The diehards, only the lucky few get to watch this live. So
yeah.
thank you, you kind of amazing people for watching actually, because
for sure
you're definitely our highest, hardest, whatever the phrase is. So we're wishing you a very happy holidays for sure. Yeah.
Bye.
All right.
Adios.
Bye.
Bye.
See you next year.
I'll